Three major parts of the model are now ready: the left wing, right wing, and rear fuselage. Now part 4, the front fuselage, the cockpit. This cockpit is made of carbon composite, titanium and aluminium. And with thousands of individual components, it's one of the most challenging parts of the model to build. Mark Jackson is head of Typhoon's production engineering.
The assembly itself was the most technically challenging aspect of front fuselage, so perhaps not one component in its own right, but to design and engineer the fuselage product against a very, very demanding technical specification.
Luckily, every one of the Typhoon megafactories gets a copy of the instructions. Operating the Typhoon's automated systems takes 45 kilometers of wires and 40,000 connections. Every one precisely fitted and thoroughly checked.
This is basically the cockpit of the aircraft. So all the flying controls, the throttle, it's like the command centre of the aircraft.
This rat's nest of cables will eventually protect the pilot's life, so it needs expert engineering.
It does look like a mess, but we make the same mess every time. It's very well engineered.
Electricians lay out each individual circuit. Then the circuits combine into one system. It's a time-consuming job.
When the looms come over, it takes about 3 days to put all the looms on, tie it together.
It then takes a further week to complete the wiring inside the fake cockpit. The replica layout is added to the real fuselage for testing. Believe it or not, this will eventually look like this. It seems cramped, but this is first class, fighter style.
The cramped impression you have, that's not really applicable, because it's for an aircraft or fighter jet cockpit, it's a really big cockpit. It's pretty roomy actually. The longest I've flown was about 9 hours with air refueling, and I didn't get tired at all sitting in the cockpit. So it's really nice. The air conditioning works. It's not really noisy up there. I mean, there's some noise, but compared to older airplanes, it's a really comfortable cockpit.
Another pilot's aid included in the front fuselage is the flight refueling probe. This allows the pilots to take on fuel during flights, greatly extending their operational range. With the electrics signed off, carbon fiber skins are added and more glue. Reinforcing sealant is spread across the joints. This protects the structure and helps keep moisture out. Then, more drilling. Just like the wings in Italy and Spain, the placement of the drill holes is crucial. This part must also connect to other parts made hundreds of kilometers away. If the holes don't line up, this aircraft will be grounded. Holes are bored for temporary fasteners. These will hold the skins in place until permanently fixed. And it's not going there until these guys say so. They check for tolerances. One of the biggest challenges for the Typhoon's engineers is making sure every part of this model lines up perfectly, no matter where it's made. Many aircraft are allowed a 25mm lateral difference along the line from the tail to the nose. The Typhoon is accurate to within 1.5mm.
We can measure anything. We can measure hull positions, surfaces of the aircraft, anything really.
This 3D laser makes sure the Typhoon's parts are perfectly aligned. There can be no surprises further down the line. The laser itself does the work of a small army.
Depending on what you're measuring, this particular job takes about an hour probably to measure, and it's about the same to analyse. Whereas if you're doing it the old-fashioned way, the expenditure of the tooling and the actual manpower on it as well, you're talking a lot longer. Maybe half a day, maybe longer.
With its major parts installed and the sign-off from alignment, Part 4 of